So we have Mufrid all the way from Norway. Mufrid, hvordan har du det?
Ha det bra. Thank you. It was nice Norwegian from your part.
All right. So today we're going to hear aligning bounded context with subdomains in legacy code. What are the three main things we're going to learn from your topic today?
We're going to learn how to apply strategic domain-driven design in legacy code. We're going to learn collaborative modeling technique called domain storytelling. And we're going to learn some software architecture stuff, 4+1 view model of software architecture.
All right. So virtual stage is yours, and we have listeners online and on site. So have fun.
Thank you. Well, thanks for this lovely introduction. Mufrid, my name, as mentioned, and work as domain-driven design coach in a consultancy called Cowork here in Norway. I just want to share one thing with you about Cowork. There is this method we apply quite a lot in Cowork, which we call title tight. And the reason I mention it because I'll be referencing to this method later on in my talk, so you might want to check it out. Now, there is one peculiar thing I want to share with you about my company, is that we are so-called leaderless company. We have no managers whatsoever. And it's all based on this book, Reinventing Organizations by Frederic Laloux. I'm aware there are some well-founded criticism about this book out there. However, as this is a personal story of mine, this presentation, there was also this personal experience when reading this book. It changed the way I look at the work itself. So you might want to read it. It will either inspire you or provoke you. Okay, so let's start with our story. We have a story about a team dealing with a legacy system. So the legacy we inherited was a product of some years of development history. It was in a heavily regulated market, healthcare. However, the team that built the thing was no longer there. Those things happens in organizations, right? People leave, people get assigned to new tasks, people want to do other stuff. So there we were, all are. Suddenly, there was only one developer left, and there were some domain experts still there, but majority of the people that build the product, they were not there anymore. Okay, it was rather mission critical system. It was system allowing physicians to prescribe medications in hospitals with some integrations with pharmacy systems, and of course putting patient safety on top, as this is a healthcare brand. The legacy we brought with us was a mix of experienced and junior developers. However, we had very little experience with this specific domain, medications. Some of us had a lot of experience with healthcare, but not with this specific domain. So how did we go on? Well, we tried to find some motivation to make the best out of the situation. So if we make sense of the domain and make sense of the code base, okay, then it will make our life easier. We will have more purposeful. We will find more purpose and more motivation. And of course, providing values to our stakeholders and users as we learn and develop our systems. So what I'll be talking mostly is those two points. How did we go on making sense of the domain, and how did we go on making sense of the code base? Okay, so let's start with the first thing, how to make sense of domain. Well, as I said, there were still some domain experts available for us. And we tried to ask them, what is the core use case of this product? Why did we actually make it in the first place? And they said, they did try to describe it to us this way. So if patient has a consultation with physician, and during the consultation, physician decides to prescribe a certain medicament to the patient. In order to do that, physician needs to find this medicine in the national database of approved medication. Now, this is what national authorities usually provide for hospitals and physicians out there. They monitor the import of medications in a country, and they maintain a list of the medications that are allowed to be prescribed in certain cases. So the physician can look up in this national database of approved medication and find the medicine she wants to prescribe. Okay, so let's assume that the physician finds this medicine and it's already approved in this list. Then she can create a prescription, send the prescription to the pharmacy, which to the pharmacy prescription delivery system, which notifies the pharmacy there is prescription here that will be collected by the patient. So this was kind of the core use case for the system. You prescribe the medicine and you let the patient collect the medicine at the pharmacy. So far, so good. Now, as a side note, what I used here is this collaborative modeling technique called domain storytelling. And you might want to check it out. There is a book out there by Stefan Hofer and Henning Schwentner. Every time I use this technique, I get very good feedback, both from the technical people and domain experts. So I warmly recommend it. Okay, so here we are understanding our first steps toward the broader understanding of the domain. And for my part, I was very much involved with the domain-driven design community. And understanding this is a complex domain, I tried to ask some questions. Okay, we should find some subdomains here. There should be some different business processes that are to some degree separate in relation to each other. So let's find those subdomains. Where are they? Okay, this could be it. We could split according to this domain story we just drew on the board. This could be the 4 subdomains: consultation, finding pre-approved medication in this nationally approved list, sending the prescription, and collecting the prescription. It could be. Why did we want to find those subdomains? Well, as team topologies teaches us, we want to reduce the cognitive load of the team. How much of the legacy system in domain and in the software itself we need to understand, just to be able to navigate through the different parts. Perhaps we could just reason about one part at a time. And then we made this assumption: if it turns out that this division in different subdomains, it turns out to be true, there should be some traces of boundaries in the legacy code itself. There should be some hidden boundaries. So we should be able to look for subdomains and find some traces of it in the legacy code. So where can we find those boundaries? Well, there are at least 2 kinds of boundaries, broadly speaking. Observable boundaries and not so observable boundaries. So observable boundaries, right? Technically, network, that's a boundary. 2 parties talking with each other across the network. Network constitutes a boundary. Both parties agree on it. If you deploy things into the containers, what goes inside the container is a part of that boundary. What's left out is not. So in both cases, you can see the boundary in a certain way. You can point at it. That's a boundary. Your organizations have multiple kinds of boundaries, teams and departments. The communication within the team is more effective and than across the teams. It's more fluent, or departments. So those are the boundaries that are easily observable, easily to relate to, easily to talk about. Well, how about not so easily observable boundaries? Well, at that point, we discovered this rather interesting model called 4+1 view model of software architecture, which was, this was a paper written in the 1990s by Philippe Kruchten, where Philippe shared with us his notion that every distributed system falls under this model. Every distributed system can be perceived through the lenses of this model. So let's examine it a bit more into detail. For each model, we have different perspectives, different stakeholders. So we start with the logical view. That's the perspective of end user. What kind of tasks end user needs to perform in order to do his or her job? What, from end user perspective, is logically cohesive, or what could be logically separate? So according to end user, some things should be present, perhaps visually, in the UI together, or be close to each other, some kind of proximity, or other things could be more separate. So that's the logical view, what your functionality in the system. When we go to development view, now there are us software developers suddenly becoming stakeholders. We create source code repositories, we create modules, we create classes and other source code structures. We may choose to keep this logical division as the user perceives it, or domain expert. So we may choose to keep things that are logically cohesive, also cohesive in development views, or we may choose to split them apart. So that happens. Things that should logically be stay together, we split them in two source control repositories, for instance. It happens. And the same thing can happen from process view. Now, then we talk about deployment. How do we deploy things? How do we package them? Perhaps we take multiple things that are logically separate and we package them into one deployment unit. It could be makes a simple deployment technique, or we make them distributed. In the physical view, we are talking about the infrastructure. Where does your code run? Is it a desktop application, mobile application, on-prem, cloud, your database with multiple nodes, and so on? And what drives the evolution of this view are the scenarios, the use cases. As new use cases arrive, we get challenged about our perception of the structure, source code structure, packaging structure, physical topology, and as our understanding of the logical parts of the system, logical perspective, gets evolved in new scenarios. And there are at least two ways to apply this model. We can establish logical boundaries without distributing across other views, or we can distribute what are coherent logical components across other views. Let me illustrate this for you. So if we try to establish logical boundaries without distributing, we could, for instance, within the same source control repository, establish two logically cohesive units that are lowly coupled with each other, low coupling between those logical units, but within those unit, there is a stronger form of coupling between the source code structures, in this case, namespaces. So we keep things within the same source control wise, we keep them close to each other, even though they are logically separate. So we establish logical boundary without distributing in the development view. And then we can keep them in the same package as well, if we want. So this is one way to apply 4+1 model, establish logical boundary without distributing. Or you can choose a certain set of classes to implement a set of business rules, and make those set of classes within a namespace, for instance, a technical authority for this set of business rules. So, meaning that this set of classes maintains the responsibility for the bounded context or the business rules that are logically cohesive. And then we can deploy them. We can distribute this same set of business rules, same set of source control structure that implements the business rules across different parts of the system. We can deploy them in a desktop application, broker application, or rules engines. So we keep this technical authority distributed, but that's the same source code. So same source code structure gets deployed on different parts of the system, maintaining this technical authority. Okay, so how can we learn that at this point of the time? So how can we go on and apply a 4+1 model in our system? Well, talking about boundaries, of course, natural question is, what about dependencies across the boundaries? What can we learn about dependencies for 4+1 model? Well, it turns out that the logical view dependencies are the reason for increased coupling. And they manifest themselves as the amount of data that is passed across the boundaries. You may, of course, desire more tightly coupled parts of the system. And that's all fine and good, right? As long as you take explicit stance. As long the point here being that it's the amount of data. The more data you pass across the boundaries, the more different parts of the system know about each other. So you can go back to your system, for instance, look at your API design and see how much data gets passed across this API boundary, meaning that your the code that consumes your API knows that much about the code behind the API. So accepting this, that logical view with the amount of data defines tight coupling, we acknowledge there is a cost of dependency in a distributed system. If we distribute if we distribute the parts of the system that are logically cohesive across development view, process view, physical view, we pay higher cost. We get more tightly coupled system that is distributed. Something to be aware of when we talk about microservices. Now, I try to define a metric for systems that are hard to maintain and hard to change. And luckily for me, Vlad Kononov is working on this book called Balancing Coupling in Software Design, where he refers to something called fractal geometry of software design. And he called this metric that cost of change is proportional to the distance between components. When I heard this talk first time earlier this year at the DDD Europe conference, to myself, I made this relation that there should be some link between 4+1 model and this fractal geometry of software design. The distance between components is a representation of how do we distribute our logical units across the different views in 4+1 model. Okay, armed with this, we go on and explore our domain and our legacy code. So let's go back to that. So we stumbled upon another use case. I mentioned that in order to prescribe medicament, this medicament needs to be in the list of the pre-approved medicament maintained by national authorities. It turned out there was exception to this rule. We still have our patient having consulted with physician. Physician still tries to prescribe a medicament. However, this medicament is not in this list of the nationally approved medications. This could be very much the case because different countries have different lists of what they constitute to be a nationally approved list of medications. And our physician, perhaps she discovers some promising research in some other country about this specific medication, and she decides that this specific medication could benefit our patient. What she can do in this case, that she can actually apply for approval of this specific medication to national authorities. And she can get the approval. The national authorities can approve her application, and then we can go on as before. We can send the prescription to this pharmacy system, which can notify the pharmacy, and patient collects the medicine. Okay. What does this mean? What did this mean to us at this point in time? Well, we saw this as opportunity to reduce our cognitive load. Are we looking at another subdomain? Can we reduce our cognitive load even further? Well, what makes a good subdomain? How about this event, non-approved medication prescribed? Is it significant? Is it what we call pivotal event in event storming? What we at least could see, there was this time notion involved. While waiting, but after sending this application for approval, the physician stops the prescription process. Perhaps patient goes back home or whatever, and they communicate after some time delay. When the application gets approved, the prescription process is continued. Okay, so this could be another subdomain. This could be, it seems that this could be a separate business process according to these parameters of time and significant events. Good. So let's try to apply this, what we learned so far in our system, trying to go from subdomains to bounded context, which constitutes more system-like boundaries in our product, and try to apply 4+1 model. So how did we go on about it? Well, we asked ourselves the question, are there any established boundaries in the development view of the system? Perhaps the team that was before us, perhaps that team managed to arrive at the same conclusion and actually try to isolate the pieces of code before. Well, let's see if that could be the case. Now, at this point, we are going a bit more into details, and this was a .NET project, and my background is mainly as a .NET developer. So the references on technical stuff will be mostly in .NET. I'll try to provide some Java counter examples. Hopefully, that might help you if you are not that familiar with .NET. Okay. So, what kind of boundaries in development can we expect to find? What kind of modules? Well, we can expect to find some .NET projects, some namespaces. So you can go on and try to locate those. And it turned out there were some namespaces in the source code that actually seem to be exclusively related to sending this application for non-approved medication. Oh, so that made us quite hopeful about our assumption. So we did a rather thorough analysis about dependencies. Could we discover logical view dependencies in the source code? So we did this analysis of using statements, .NET project references, NuGet package references, were there any distributed calls, were there any events going in and out from the system. This was rather time consuming, but essential because as far as we could see, it confirmed our assumption that there were different subdomains, and in that way we could go on and establish explicit boundary and explicit bounded context in the development view. So speaking in domain-driven design terms, we draw a context map. We assume there should be two contexts in the system, prescription-bounded context and application-bounded context. And there should be dependency between application-bounded context towards prescription-bounded context in what we call this conformist relationship in context mapping. So we assume our analysis showed us this could be the case. There are different parts of code dealing with different parts of logical parts of the system. However, when we deal with legacy code, we need to show some respect, right? We need to respect existing dependencies, relationship. So we were talking about, okay, let's try to agree on how much time do we need if we choose to break things apart. We still want to keep the business running while we made improvements in our software architecture. So there we are. Try to make, let's go on and make a decision. So this was our decision. We are going to establish this application-bounded context. Our analysis so far, we confirmed that this could be the case. There should be a subdomain for sending the applications for non-approved medications. We saw some traces of a bounded context in the source code, and we could make those traces more visible. We make them more observable, more visible by establishing a separate module within the same source code repository. So in .NET, it was a Visual Studio solution. However, we agreed that we were not going to change the core bounded context. Prescription should stay the same. 1 week, we gave ourselves 1 week, all developers, hands-on, and whatever happens, we're going to summarize our lessons and learn from it. And this is actually an implementation of the titleless type I was referring to. We tried to agree on a goal or purpose. So our goal was to reduce our cognitive load, to be able to understand the domain better, to understand the legacy system better. That was our goal. How do we go on achieving it? Well, there are different ways to do it. You let the team be creative, and our choice was to make boundaries more explicit, meaning that we could reason about only one bounded context at a time. And after we tried our experiment, we are going to summarize and learn our lessons. So this is kind of titleless type on this specific implementation. And just to remind you, our choice about implementing 4+1 model in this case was establishing logical boundaries without distributing. So we chose to keep everything within the same source control repository. This system had one or mostly one repository. We chose to keep things within one repository, but we are going to make this logical boundaries more specific. Okay, let's go on. How did we, what did we make out of this? So step one was to establish a new module, Visual Studio Solution. In step one, we just moved the code around. We just used Git and moved one code from one module to another within the same source control repository. Our code compiled and unit test run. So far, so good. However, very quickly, we ran into this dilemma. What about our integration tests? Okay, what do we mean by integration tests? I guess there are different definitions out there. Well, any kind of test that span multiple components and give you some kind of realistic feedback on runtime behavior of the system. Those tests are, they take longer to run, they're harder to maintain, but they give you this runtime feedback. Or you can say that tests that do not rely on mocking out dependencies or not mocking out every dependency. So using tests usually mock out dependencies. Integration tests usually do not do that. So should we work on them or not? Because at this point, the tests were failing. Unit tests were running, but the integration tests were failing. If we work on them, we could get this more realistic feedback on bounded context, subdomain alignment. However, just to make them running, we realized that it would need a considerable amount of work. Perhaps we could use our pre-defined time box without actually getting anywhere. So this was kind of a dilemma. And we decided just to focus on unit tests at this stage. It seemed like a good idea at the time. Okay, step two. So we moved the code around in step one, right? And where we moved code from, there were some references that should have been obsolete because the code that was referenced was moved. And in our, we believe that those should be rather quickly, those references should be rather quickly, we should delete them rather quickly because they were just pointing at nowhere. The real references were to the code that was moved to another module. And this was a rather important step. So we went through this .NET project references using statements that should have been obsolete. We just tried to remove them. However, we uncovered hidden dependencies. It turns out there were some classes and interfaces in this core context, prescription-bounded context, that actually referred to application bounded context, the source code representing sending of application to non-prescribed medications. Of course, we didn't want this. This is a circular dependency. We don't want this. So what we applied is what we in domain-driven design context mapping called shared kernel. So instead of prescription-bounded context, referencing in step one, application-bounded context, so we moved the types from application-bounded context to this shared kernel module, and then we made both of those modules reference the shared kernel. So we removed the source code that referenced prescription-bounded context to application-bounded context. Okay, so far our assumption still holds. We are able to establish a new bounded context in our source code repository, and we have this assumption about references still valid. Application-bounded context is only referring to prescription-bounded context, not the other way around. Okay, now we can get those end-to-end tests running. And that was it. End of the story. Didn't work out. It turned out that some end-to-end tests or integration tests in prescription-bounded context required code from application context runtime. And it was a valid business reason for this. So we had this logical circle of dependencies that was, it turned out it was required by the use cases. And the requirement we discovered was, while prescribing a non-approved medicament, physician needs to see prior applications. In cases for lifelong treatment, the same application, the application for the same medicament gets sent over and over again. So the physician needs to see, did I send this application before, or perhaps it's out of date or something. So this actually required dependency from prescription-bounded context to application-bounded context. It seemed like there was this business requirement for that. Okay, we didn't give up at the time. So we tried, okay, can we avoid those circle dependencies? Can we, if this is integration test, right? The production code is perhaps okay, but can we just get these things up and running? Can we move all the integration tests in one module? Can we make this? Can we establish another module in the same repository which contains all integration tests, and then that module can reference the code from both contexts and make the tests run? It could work. However, this production code dependencies was going in two directions would still be there. So deployment-wise, remembering 4+1 model, this could work as long as we package everything together. So we development view, we could get things distributed or separate. Logically, there would be this circle of dependency, and it would work as long as we package everything together. We do not distribute in process view. Okay, so it didn't sound like a good idea, so we stopped this experiment. Okay, so now what? This lovely gang of fishes from a great Pixar movie, Finding Nemo. They had a really good escape plan, and there was this. It didn't turn out as they as they perceived it. Okay, so perhaps we could analyze the needs behind the business requirement. As a physician, while prescribing a non-approved medication, I need to see prior application, okay? I need to see to be able to prescribe. So physicians need to see prior applications. The goal is still to prescribe. The main reason to do this is to prescribe. The prescription process is the goal. What's the action? You need, while prior applications are kind of decision support. So we need to show data to our user as a decision support, which means we need a read model. The actual behavior in the system is still prescription. So these things seem to be separate. Now at this point, we ran out of our 1 week time box, meaning that we didn't achieve what we needed to achieve. However, there were some lessons learned. What we could do, what we saw in Aftermath, what we could do is to go from this kind of design, where there are a front end for prescription-bounded context, allows user to prescribe the medication and show past applications, through this server-side dependency, where prescription backend goes to application backend and executes a method called find past applications. leaving the application front end just to show the form for for sending the application to national authorities. So this was the state of the system, and the reason we had this circle of dependency. This goes right, and dependency front end goes from left to right, on the back end from right to left. What we could do is to move the dependency to the front end. Just let the prescription front end only contain the functionality for prescribing the medication, while application front end could both provide this form for filling the application and showing the past application. This technique is called view model composition. I wrote a blog about this after some time after our experiment, and I got a suggestion from Mauro Servienti, who read my blog, and he suggested actually this view model composition pattern to compose data from different bounding contexts on front end. It's rather powerful technique, and I suggest checking Mauro's blog. He has lots of articles on it. Okay, so what did we learn from this? Well, we learned quite a lot. As this kind of caught us a bit by surprise, we decided to conduct regular architectural reviews. And we decided to establish a target model. How do we want the system to be? And we decided to pay more attention to logical dependencies. And one more thing that I'll get back to. So these architectural reviews are weekly meetings where we try to learn about boundaries. We try to go through the source code, try to see what can what have we learned so far. Are we observing new boundaries? Can we insert some boundaries? And it really makes me proud that my former team still does this to this day. And going back to this domain storytelling, perhaps what we learned is perhaps we could ask different questions. Perhaps we denoted our actors in domain stories rather general. Patient, is it only patient? Physician is only physician. Perhaps physician, we can go in more detail. Perhaps we are talking about neurologist, cardiologist, gynecologist. Perhaps not all of them need to send applications for non-approved medications in the same way. Perhaps the domain stories would look different depending to what kind of actor, what kind of physician, what is his or her specialist field. So by naming the actors more generally, we seem to be pulled towards more general model. So this could be one lesson to try to go a more nuance in when learning about domain. Target model. Let's define the model. How do we understand the domain? How do we want system to be? And let's work towards it. And during a code review, we can discover logical dependencies, not just by paying, and not just by looking at the tests and production code, but paying particular attention to introduction of new references, questioning the intent behind. This requires discipline. And but if you pay some attention, you can ask some question. Did you actually mean to introduce a new reference? And you can always make things more cohesive. And this great talk by Kent Beck, to make things cohesive is easier than to make things to separate things, as we have just learned. So we can start by keeping things apart for a while until we have learned what things are. And then if they seem to be separate, we keep them separate. If they seem to be the same thing, we just make them more cohesive. Okay, I have a little bit time left for what I call the most important part of my talk. I hope you enjoyed this so far. I certainly did. Thank you, but please give me a moment to introduce you or perhaps present you something that you're already aware about. First, Lego League. It's a competition in robotics and research for kids aged 10 to 16 years. There are teams all over the world, and I will encourage you to use a bit of your time, devote a bit of your time to help those teams in your part of the world. And if you want to help, this is my team, Techno Builders. They are 12 years old. They started to use, all of them use how to use Git. So they will be really happy if you can follow us on our Git repo and give them some boost for their future robotics endeavors. Thank you very much.
Thank you, Mufrid. That's a very nice involvement for you to be in a team and all with the kids. Thank you for sharing. Do we have any questions? No, and we don't have questions online. So Mufrid, tusen tak, and see you next year.
Absolutely. Thank you very much for having me.
Okay.
Thank you.
I'm saving the coral reefs using underwater AI.
I'm helping food get to those in need, fast.
I am reducing waste in the global fashion industry.
I'm helping make live theatre more accessible for the hearing impaired.
I'm securing our future.
I'm disrupting the world with quantum computing.